This is worksheet 8-2A. Looking at the product of powers and the power of powers. So question number 1 says we're going to write the expression in expanded form. We're also going to write the expression as a single power. So as we look here at number 1, we have 10 times 10 to the 4th. Anytime we have a base, there actually is an exponent of 1. And this property says when you multiply similar bases, the exponents get added together. So we're going to show this in expanded form so we can make sure we understand why this property works. So first of all, 10 to the first is just 10. And you're timesing that by 10 to the 4th, which is 10 times itself 4 times. 2, 3, 4. So it's 10 times 10 to the 4th. So this is the expanded version. And if we're going to express this as a single power, you can notice it is the same base being multiplied 5 times. So this is 10 to the 5th. And so this shows that the property holds true. Multiplying a similar base, the exponents get added together, and it's 5. All right, number 2. N to the 3rd is n times itself 3 times. It's being multiplied by n to the 5th. So that's n 5 times. And now if I want to go ahead and just combine all of that as a single power, it's the same base, so I can put it all together. There's 8 of them. So it's n to the 8th. So again, when you're multiplying similar bases, you add the exponents. Okay, number 3. We have negative 7 raised to the 2nd. That whole expression is now being raised to the 3rd. So it's going to happen 3 times. So first of all, negative 7 raised to the 2nd. Let's just expand that. That's negative 7 times negative 7. That's negative 7 to the 2nd. This whole thing. This whole thing has to happen 3 times. So it's going to get multiplied here, and then it's going to get multiplied here. So inside of this is negative 7 to the 2nd. So here's negative 7 to the 2nd. Here's negative 7 to the 2nd. And here's negative 7 to the 2nd 3 times. So negative 7 to the 2nd expanded, multiplied by itself 3 times. In the end, there's 6 of these similar bases. So it's negative 7 raised to the 6th. Over here, this is m to the 4th, which is m times m times m times m. That's m to the 4th. This whole expanded form is being raised 3 times, so it's being multiplied by itself 3 times. And then if we combine all of this, it's all the same base, all being multiplied together. This is m to the 12th. So looking back at both of these, our end goal is to be able to skip the expanded form and just go straight to our single power using the property. So we did 2 times 3, we got 6. We did 4 times 3, and we got 12. So very simple multiplication, very simple addition, but we have to be careful. It's very easy to just make a mistake and go too fast and just add 4 and 3 instead of multiply, or multiply 3 and 5 instead of add. So we just have to make sure we're being cautious of what's going on. So as we move down to number 5, similar bases being multiplied, that means we add the exponents. So this is n to the 8th. I'm going to move straight down. Now I have a power being raised to a power. So this is n to the 6th twice. So I'd have 6x's times 6x's, which would be altogether 12x's. So the property says I can multiply when I'm raising a power to a power. Number 9, you have 0 and 2. Following this property, I'm going to multiply. This becomes k to the 0, okay, when I raise it. And we studied earlier that anything raised to the 0 power is 1. So final answer here is just 1. All right, we have this 5, 6 coefficient. There's no exponent on it. There's just a 1. And so we're just going to worry about expanding and writing this as a single power. So we're raising a power to a power. Notice the 5, 6 isn't inside the parentheses. So that's not being raised to the 3rd power. The 5, 6 is just going to stay. We're not going to do anything with it. If it was inside the parentheses, we would have to raise that to the 3rd power. Okay, but the power is only going to q to the 4th. So q to the 4th raised to the third, you multiply, and this becomes q to the 12, 4 times 3. And that's it. All right, moving to the other side. This is really y to the first. So when I multiply here, I'm going to add these together. This is y to the 9th. Now here, we've got some multiplication. These powers are only on the p's, not on the numbers. So we can multiply like we normally would. Negative 2 times 8 is negative 16. When I multiply a p and a p, I have to add the exponents, and that is p to the 7th. I can only combine similar bases. I'm going to leave them separate here. So the a and the a can get multiplied together. The x and the x can get multiplied together. And so when I combine my a's, that's a to the 9th. And when I combine my x's, it's x to the 15th. And they're just going to stay connected next to each other like that. I can't put them together. Okay, I can't call this a x to the 24th. If you wanted to add those together, can't do that. They are separate. All right, and number 12. Similarly, this is all getting multiplied together, but the w's and the x's in the end will have to sit next to each other. So the w's are going to combine and make 8. And the x is not being raised or multiplied by anything, so it's just going to stay. And down to the bottom, we're going to write a multiplication problem that uses the product of powers property to get an answer of a to the 14th. So yours may not match mine, okay, but you needed to write some kind of multiplication problem. It's a to the something times a to the something equals a to the 14th. And so we know that these powers are going to get added together when we multiply similar bases. So we just need two numbers that add up to 14. So I'm going to put 10 and 4. The book answer had 6 and 8. Any two numbers that add up to 14 will work fine. Okay, number 14. Write a power problem that uses the power of a power to get an answer of b to the 10th. So here we have to get an answer of b to the 10th. We're taking b with a power and raising it to another power and getting 10. Now, we know that we are multiplying these two numbers, okay, just like we did here, 4 times 3. So we need numbers that multiply to 10. I think the easiest thing would be to use 5 and 2, and you can put them in either spot. It doesn't matter. These two numbers will get multiplied and give us 10. 15, using the power of powers property, Roberta wrote a to the 20th as a to the 5th raised to the something. Find the value of x. So we have a to the 5th being raised to something, and it's coming out to a to the 20th. So we know when we raise a power to a power, we multiply. So we're trying to figure out what number should go here so that we get a 20. 5 times something gets me 20. So that would be 4. And so this x right here is 4. And 16, using the product of a power property, Kenji wrote n to the 13th as n to the 5th times n to the something. And again, it came out to n to the 13th. And so we know that when we multiply similar bases, we are adding these exponents. So we're trying to figure out what number would go here. So when it's added with 5, I get 13, and that would be 8. And so x equals 8.